Okay, thank you so much for the introduction. Hello, everyone. Thank you for your interest in the topics of GeoAI. So basically, today is in the topics of GeoAI, object detection, and predictive analytics. Basically, I will share to you about three main things, which is I will share to you the foundations of GeoAI and how actually Esri come into the picture. And I will also share to you the capabilities of the GeoAI and actually how you can actually apply it to your own needs. And the third things I will actually share what Esri Malaysia have been doing for the past few weeks on developing certain things on GeoAI capabilities. So I'll start with the introduction. This is where I will set the foundations, whereby if let's say you are new to the field, basically you can actually read a lot of things that relate to the object tracking, for example, the cognitive computing, machine learnings, and neural networks, for example, and all of these words basically can give you a overload of information, and it is quite intimidating for beginners. So here I would like to actually highlight the core concepts of GeoAI. From here, you can basically see that AI is basically divided into these three main concepts, which is the artificial intelligence itself, which is actually resemblance of the human's capability and ability of human to make decision making through machines and computers. So the next thing is basically in terms of machine learning, whereby it is a data-driven approach where we give a certain inputs to the machine, and the machine will actually digest the parameters that have been given by us and come up with a set of output from there. And the third one is basically in terms of deep learning. Okay, deep learning is basically how the machines actually compute using his own artificial neural networks, and from there he will actually make his own decision. For example, you give a certain input and the machine basically will learn from it, and we actually learn whether the surface actually come up as a certain indicators for certain features to be recognized. So actually the machine keep on learning by itself in terms of parameterizations, in more as an automated process for the machine to learn by itself. So when it comes to the artificial intelligence, machine learning, and deep learning, we can actually conclude that machine learning is basically the subsets of artificial intelligence, and deep learning is the subsets of machine learning. Okay, from Esri points of view, we can actually say that we are not developing AI as a one product. We are actually working hard on embedding the GeoAI capabilities across our ArcGIS platform. So from here, basically you can actually see that we have been working on embedding these GeoAI capabilities into the ArcGIS API. For Python, for example, we have lots of examples. We have lots of resources that you can refer to for in terms of scriptings or in terms of Python scripts, all inside our ArcGIS API for Python resources. And in terms of ArcGIS Notebook, basically ArcGIS Notebook is a resemblance of Jupyter Notebook. But we have made the Jupyter Notebook within the ArcGIS Pro to ease our user to basically use it within the ArcGIS Pro environment rather than you are going outside from the ArcGIS Pro environment. So we also have embedded the capabilities within the ArcGIS Online and Enterprise, where you can actually leverage the use of, for example, an image server to actually do a parallel processing for your own imagery GeoAI workflow. And right now, there's also a direction where we actually work on embedding these GeoAI capabilities in field mobility applications, such as quick capture and also ArcGIS Survey 123, which is it integrate the Survey 123, for example, with the TensorFlow frameworks to actually do the data collection and object detection automatically within your mobile devices. So now how we can actually unfold this GeoAI capability in the ArcGIS technology. So the first part that I would like to show is basically these are the things that we've been working for almost decades actually. We've been doing classifications of imageries and land use and cover, for example. So we are not realizing that actually this is a part of the GeoAI capabilities. So now actually I would like to classify that classification is also a part of GeoAI capabilities. clustering, you have been doing your space-time mining for certain clustering and pattern detections within this ArcGIS Pro. So these are one of the things that we've been doing for the past few years. Prediction, we actually use the certain parameters and these GeoAI capabilities to predict certain things. And now we are moving forwards to deep learning application, where you want to actually enhance the use of all these classification tools, clustering tools, and prediction into a more detailed structures of object detection and prediction capabilities. Okay, the three main patterns for GeoAI. So over here, we can actually come back to the part whereby we can actually do an object detection from the GeoAI, where you can actually detect objects, anything from imageries and from videos, anything that you can actually see from your eyes. Basically, you can actually inference from that, and so you can train the machine to actually do the works for identification for you. For example, you want to actually detect buildings, you want to detect swimming pools, anything that basically relate to your organization's needs. So in terms of prediction, for example, you have the whole hydraulic mappings of a certain area, and you want to actually detect a certain pipe burst over a certain area. So we can actually input those important parameters, and then we can actually predict where are the areas that are prone to a certain breakage of pipes network, for example. In terms of pattern detection, basically you want to actually find statistically significant clusters of pattern. For example, where is the place of emerging hotspots of 999 calls. So this actually give us an overview and knowledge in terms of certain things for us to actually do a further analysis. Okay, basically from the release of ArcGIS Pro 2.5, Esri has actually embedded the whole ArcGIS Imagery AI workflow within the ArcGIS Pro. So basically we have done, we can basically do image management as in the previous version of ArcGIS Pro, but now the one that I would like to highlight here is that these four components, which is the labeling parts. So the first part is we label the objects that we want to actually detect. And then from there, we actually prepare the dataset to be as an input into the training the model. So this can also be done as a part of the process within the ArcGIS Pro geoprocessing tools. And then from the ArcGIS Pro 2.5, basically we have developed a user interface, a geoprocessing tool for the trained deep learning model. So you can actually use it without the needs to actually go into Jupyter notebooks. So you can actually use the geoprocessing tools to actually conduct the model training process. And then after that, you can actually inference back the trained model into, for example, other images. So you want to actually detect the same object that you trained just now, and you want to apply it to the larger area, for example. So we can do as an inferencing process. Okay, the next thing that you can do is basically you can actually conduct analysis from there. You have actually detected your object, you have other information, and you want to incorporate that information within your workflow. So these are things that have already can be done with ArcGIS Pro. And then you can actually, publish your detected objects and the analysis that have been done into ArcGIS Enterprise or ArcGIS Online, for example. So the summary of this ArcGIS Imagery AI workflow is basically that we can say the ArcGIS are being used for each steps of the deep learning workflow right now. So you don't have to actually being a programmer or anything, you can actually simply use the geoprocessing tool within the ArcGIS Pro 2.5. These are some of the initiatives on how we can actually explore the endless possibilities of deep learning. For example, over here, we can actually detect building footprints. Certain organizations are interested with the building footprints, and certain organizations actually would like to actually embed certain information like a damage structure from earthquake or any for flood event, for example, into that building footprint. So this can also be used as a classification tool within the deep learning workflow. And we also have an example. For example, here we have a catfish identification. For example, there's a full motion video taken from a drone imageries, and then you want to actually classify certain objects on the ground. From there, you can also you can also extract from different frames of that video to actually conduct an automated process of object detection. Okay, without wasting more time, basically I will go through the demonstration parts, whereby, okay, on this demonstration part, I will actually showcase on how we can actually utilize a GoPro video and also a TensorFlow framework to actually come up with the object detection. So the main focus of this demonstration is basically to highlight the effectiveness of deep learning, especially right now in the case of COVID-19, where we're facing a global event which is impacting our social and economic activities around the world. So how can actually we use this GoPro video that we can see? Okay, from here, basically, I've taken a GoPro video footage along the Kesas Highway. This is basically taken shortly after the phase of recovery movement control order. So actually, right now, we want to actually monitor what are the car activity, how many cars are there on the road to actually monitor the activities, and how we have actually improved from the previous periods of the movement control order. So from here, the question is how we can actually extract all of these vehicle informations automatically without actually need to tag every single cars, or maybe you are interested with the road signs, the road assets such as lampposts and road signs. They are part of things that we can actually detect from the TensorFlow workflow. In the next step, basically, I will share to you how we can actually do this within the TensorFlow workflow, the TensorFlow framework. So over here, you can actually see there are two sets of data sets, the test sets and also the trains data set. So from here, actually, the test and the train data set were actually extracted from the frames, the video frames that taken from the GoPro videos. And then over here in the train data set, we have around 227 data sets. And then in the test data set, we have around 100 samples of data. So from here, basically, you want to actually use these frames to actually extract a certain features and then become an input to the model itself. So basically, the one that we use to label all of the features of our interest, for example, in this label image tools, basically I have identified few objects of my interest. For example, you can see on the right side of the screen, there's a vehicle that I have extracted from that I have labeled from there: the traffic light, the road signs, the street light. And let's say, for example, here you can see that I've labeled most of the features in the image, and I've missed one of the vehicles on the right side of the image. So basically, I label it, and then I will actually label it as a vehicle, and it will be added up as another classes into the label image tools. So from here, basically, you can see that actually the tools generated an XML file that is later transferred into a CSV file. You can see here that actually every classes of the label imageries are basically stored within this CSV file. So this is basically the train label data that we have identified, and this is an input that we want to actually put into the TensorFlow framework. So the one that you're seeing right now is basically after I've applied the train data or the label image into the TensorFlow framework. You can see that I actually run an iteration up to 60,000 of iterations, and over here we can see that the iterations takes about 0.4 seconds per step. So basically, the main components here is that we need to actually identify the important things, that how much is the time taken that we actually use to actually train the models. That is actually what will determine how the models works. And then how much is the number of samples that we actually put in the train and also the test that I've shown earlier. So these are the two main components that actually will contribute to the accuracy of our inferencing later on when we apply back all these identifications on the object detection. So as you can see right now, this is actually an output that come out after about 60,000 to 70,000 of iterations. So basically, it come out fairly good and fairly good enough for me. I think we can actually see the percentage is actually indicating the confidence level of our object detection. You can see the road signs identified up to 99% over here. So this is basically how we extract all these informations automatically later on, where we transfer it into the ArcGIS Online or ArcGIS Enterprise. Okay, from the videos that you've seen earlier, we have actually automatically detected certain objects based on our needs and interests. So over here, this is how actually we leverage the use of ArcGIS Online or ArcGIS Enterprise, whereby we use ArcGIS dashboard over here to actually count the numbers of vehicles. You can see here there's around 145 detected vehicles, 34 detected road signs, and 38 detected street lights on these few frames that have been taken along the Kesas Highway. So on the left side is basically the confidence level. So you can see the distributions of confidence levels across this Kesas Highway. So let's say I selected the 67 confidence level. I want to actually do a quality checkings on these extracted objects. You can see here that basically it detected a road sign with a 60+% of accuracy. But over here, basically the things, the road sign extracted is basically correct. However, the distance is quite far away. So basically the machine, even though it gives a quite low numbers of confidence, it still managed to actually give out a good outcome from there. So let's say we want to actually go through from a certain parts of the Kesas Highway. We can see that from the earliest extents of these GoPro video captures, we can see the distributions of cars activities over the areas that we want to actually monitor. And from here, we can actually see from single points, actually there are 4 attributes that's been collected over here, which representing different classes of object detected. We can see that vehicle with 75% of accuracy, with 3 numbers of vehicle in a single frames. Okay, over here we have, let's say we actually want to detect the road signs here. We wish in the image, basically it detected 4 road signs, and we can actually quantify as a verification process after we did the inferencing process. So this is a way that you can actually automate all the extraction process and directly feed it into your ArcGIS Online or ArcGIS Enterprise for the use of management for decision-making process. I would like to actually share another example over here. This is basically a CCTV live feed that I've taken from a YouTube video, basically this one. But I've done this demo because I don't have any access to the CCTV live feed. So this is actually a CCTV live feed from Plaza Bamboo. And then over here, I want to actually detect individual big boats or small boats from a CCTV live feeds. For example, you want to actually monitor activities on a certain area. You want to actually monitor activities, let's say you want to transfer these information back into the ArcGIS Online or the ArcGIS Enterprise. All that we can actually do is actually link these things back to the ArcGIS Enterprise and ArcGIS Online, like what I've done with the Kesas Highway. And then this is the examples of the video. This is example of the dashboard that shows use cases that we can actually apply in terms of COVID-19. For example, this is an activity detection in Washington, D.C. using machine learning and ArcGIS, which is every point on the map is basically representing single CCTV cameras around Washington, D.C. So you can actually see on the left side of the dashboard basically is a time difference from each detection and which area that are being detected. So from there, you can actually monitor from different time frame. For example, in the morning or in the evening, which are the areas that are prone to a certain activities. So this is a way that you can actually apply. As a resource mobilization, for example, a police force to optimize their resource mobilization. So the key takeaway from my presentation is basically that we want to actually understand how what is the difference between AI, machine learning, and deep learning, and how we can actually apply in the context of GIS. And basically, GeoAI is not one product. It's spanned across our ArcGIS platform. And the third one is that we want to actually explore the potential of GeoAI capabilities in object detection and predictive analytics together with our users. So I think that's all from my presentation today. I will actually pass the floor to the Q&A session. Right, thank you.